All right. Good morning, everyone. I want to welcome you to this month's installment of the From Research to Implementation webinar series. We've got a fun topic today. We're going to talk about the bond strength testing of asphalt pavements. Bond is so important there. We harp on tack all the time to try to make sure we get a good bond there. So with us today, we've got Nathan, as always. We've got Randy, our director at NCAT, and then we also have Sean Jack from West Virginia. So Nathan's the assistant director for test track research at NCAT. He oversees all the test track testing programs. Prior to that role, Nathan served as a lab engineer for 8 years in the NCAT lab. He specializes in BMD and pavement friction. He has both a bachelor's and a master's degree from Auburn University in civil engineering, and he's also licensed in the state of Alabama. He also has a knack for finding his own Odyssey, even if that's a Honda Odyssey. Randy's the director and research professor here at the National Center for Asphalt Technology at Auburn University. Somehow his bio says, and the best boss I've ever had. Not sure how that got in there. He's worked as a pavement engineer for 38 years, including the last 22 that he's been here at NCAT with us. Prior to NCAT, he worked for APAC Incorporated for 7 years, managing corporate technical services group, and he began his career with the Florida DOT as a bituminous research engineer. Randy is a proud grandfather of several grandchildren, and he's a retired amateur skydiver. If you know, you know. Sean Jack is the asphalt section supervisor, which is really everybody else knows that by the state asphalt engineer. That is in the West Virginia Division of Highways under their materials division, which is called Materials Control Soils and Testing. He oversees asphalt material testing, specification activities, asphalt pavement construction, and preservation efforts all across the state. Sean's actively involved in specification development, quality assurance, and collaboration with industry partners and contractors throughout the state of West Virginia. Sean brings really strong practical perspective on asphalt materials and construction, and Sean owns many fine guitars. Given that, I want to remind everybody that we'd like you to stay on mute. We're going to ask you to type your questions into the chat box. We'll answer those at the end, and we'll see you on the other side. Nathan.
Great. Thank you, Travis.
You bet.
Must be performance review season, Travis.
He gave me that bio. I don't know.
All right. Well, good morning, everyone. So those of you who are frequent attendees, you know the drill. But those of you who might be new, and I see we still got folks joining in the chat. I mean, in the weight room. So Travis, let's make sure to let everybody in. So I'll introduce the topic, and then we'll hand it over to Randy and Sean to get a much deeper dive. And then at the end, we've got questions. So I want to reiterate what Travis said. Please, 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 as you have questions, go ahead and get them in the chat. Sometimes our presenters are able to go ahead and respond quickly. Other times it sparks wonderful discussion at the end. So bond strength, issues. This is a very common issue. You see it frequently whenever you're driving around. It happens a lot at intersections. Anytime there's slow moving traffic as well. One of the rules of thumb that I learned is anytime the pavement is smiling at you, that's typically a bad sign. There's something going on below it. So that's really important. As it relates to testing at NCAT, we've been doing bond strength testing now going back to the 2000s, so over 2 decades. I like remembering the old Marshall press with this the old paper here, and so here's an example of a bond strength test, and it's very common. You see it kind of reach that peak and then quickly fall off as you break that bond. Randy's going to talk a lot more about bond strength testing and development of test protocols and procedures, specifically what we did for ALDOT. So I don't want to steal any of his thunder. But just to kind of prime the pump as I begin to hand it over to him, lessons learned over the years. It's funny that lessons learned are based. I mean, they're very much back to basics. Clean surfaces are critical to achieving good, strong bond. There's lots of way to achieve a clean surface, and Randy will talk some more about that. But if you have a bunch of debris and dust on the surface, that is a recipe for disaster. Milled surfaces will promote higher bond strength than versus unmilled. Sometimes, you may not be doing a mill and inlay, and so you don't necessarily have the option. But historically, milled surfaces, they do provide higher bond because not only do you have the bond from the material, but you've got mechanical interlock between between materials and the two layers. And tack material, it matters and it affects performance in varying conditions and over time. So with these as sort of a priming the pump, I really want to kick it over to Randy and let's learn a couple things.
Well, good morning, everyone. I think that this topic of bond strength is one of the most overlooked issues in pavement construction, pavement performance. So I'm glad that you guys are tuned in to kind of hear what Sean and I have to tell you. Um, all right, so first we'll talk about what is the function of tack coat, and then I'll cover what can happen, when the tack coat is not properly applied. And then the question that I want you to think about is how can you tell if your tack coat is sufficient? So what is a tack coat? It's a thin bituminous liquid asphalt, could be an emulsion, it could be a liquid, hot liquid asphalt binder. Some states may still use cutbacks, although I think that that's pretty much gone by the wayside over the decades. But it's applied between asphalt layers, or it could be on top of a concrete pavement to promote bonding between those layers. We want the pavement to act as a monolithic layer. For years we've said building an asphalt pavement in layers is an advantage for our industry. But if those layers do not bond well and we don't have them behaving as really a single lift, then we're going to have trouble in terms of the pavement performance. As Nathan mentioned, kind of slippage failures are an obvious distress that's caused by poor bonding, associated with a lot of times with braking, could be as well as acceleration, but there are other forms of distress that also stem from a lack of bonding. You see this pavement here, you may think, oh, that's top-down cracking or bottom-up cracking. But if you take cores, from a lot of these kind of pavements, you'll see, oh, there's a debonded layer there. And that is contributing to the cracking that you're seeing on a lot of the pavements we have. So what appears to be fatigue cracking may actually be due to a bond failure. So let me explain that a little bit. This illustration shows a three-layer asphalt pavement, and the top part is where the interface between the base layer and the intermediate layer are fully bonded, and then the right side of that picture shows kind of the mechanistic analysis of the strain level at the bottom of that asphalt. Because as that pavement is loaded, it's going to bend, and we have tension at the bottom, compression at the top. If that layer between the base and the intermediate layer are not bonded, then you actually get a higher strain at that interface between that base layer and the intermediate layer than you would for the strain at the bottom in a fully bonded condition. And that higher strain is often what leads to premature failure of the pavement. So you're getting a higher deflection with an unbonded pavement. That higher deflection is indicative of higher strain in the pavement structure, and that strain is going to lead to cracking. I'd like to share with you, you may have seen this before. I think it is an excellent demonstration of the importance or the effect of bonding. And this was slides that were put together by Dave Johnson with the Asphalt Institute. And what he did was to cut 5 plywood strips representing asphalt, layers. Each strip is 4 feet long, 4 inches wide, and the plywood is 11/32 inch thick. And he applied a load to those plywood strips sitting across a couple of sawhorses. So on the left is where those plywood strips are not bonded. There's nothing between there in time of glue or anything like that. He put a 60-pound weight on there and he got a 1/2 inch deflection. The right side shows if those layers are glued, they're fully bonded. And in this picture, you can see he added 160 pounds and had only a quarter inch, half the deflection. So I think this is just an excellent demonstration of what we're trying to achieve with with tack coats and bonding of pavement layers. As Nathan mentioned, we've had occasion to observe this on the test track. Back in 2007, we had section S5 that had fatigue cracking, and you see the little picture in the inset there showing a core taken out of that section, and it came out with a debonded interface between kind of the base and the intermediate layer. And we went back and looked at pictures of the tack coat that we had during construction, and it's actually a pretty decent application of tack. A little bit rich, kind of in the right wheel path, but not too bad. Anyway, so it wasn't like, oh, there's something wrong with what we did for the application of the tack coat. But we ended up with premature failure of that section. This series of cores was taken as part of our forensic investigation. And we just found cores as we were coring this pavement up to try to figure out what was going on. And so what we found is core number one shows, the core came out intact. There's no delamination or no break in the bond. But core number two, there was a debonding occurring when the core came out of the core hole. Core number three, you can see the little arrow pointing to a small crack that is starting to occur at that interface and working its way up through that intermediate layer. Core number four shows where that same, well, not the same crack, but a crack has then worked its way up from that debonded interface all the way to the surface. And then core number five is where the pavement is really damaged because of that weakness, that bond issue. The cracks are working its way from the interface to the top, and that lower layer is also cracked now in that particular core. So this is kind of the phenomenon that we see with a debonded or poorly bonded pavement construction, and it will lead to premature cracking, premature middle up, or even continuous progression of cracking throughout the pavement structure. Throughout my career, I've had the opportunity to be involved in a number of forensic investigations in Florida, at airports, on U.S. highways, in Alabama, a couple places, in Minnesota, in Colorado, to name a few. On those projects that I mentioned, we took cores as part of the forensic investigation and found delamination or found debonding between pavement layers. And sometimes you can see that there is a tack coat there. You can sometimes see a little bit of a dusting. That dusting can be an indication that those layers are working against each other and creating kind of a grinding process. And that's the sign that the failure is imminent. And then you see on the right hand picture there a crack that's developed, in the surface from that debonding. So it is a common problem. And the way to really figure out if you've got this issue in pavements is to core. That's the only way to figure it out. You're not going to really figure this out by doing FWD testing or even ground penetrating radar unless there's water at that interface. So I'm going to back up now to the first study that we did at NCAT back in 2003 to 2005. The objective of this project was to determine what is the best type of tack coat material and what is the best application rate. Well, we start out with a literature review, and there were a number of countries in Europe that had bond strength tests. Many of them were shear tests, although Austria had a tensile test, the UK has a torque test. And then I think the Florida method is very similar to the method we talk about later in the NCAT method, but it was developed probably about the same time that we were doing this study. So anyway, we end up using a procedure much like is used in Germany, shown there, where they shear test with a normal load applied as a factor in the experiment. So it was a laboratory. It started out in phase one as a laboratory experiment. We prepared gyratory specimens, did 2 replicates per test. We used 3 different types of tack coat, 2 emulsions, and 1 PG binder. We ran 3 different application rates. We did mixes with a 19 millimeter coarse mix and a fine 4.75 millimeter fine mix on both the upper and lower layers. We did 3 different test temperatures, and we did 3 different normal loads. That's kind of the load being applied to the face of the specimens as the shearing is occurring during the test. The way we prepared the specimens were we first compacted the mix, the 19 millimeter or the 4.75 millimeter in a gyratory. Then we cut it in half, and then we applied the tack material to the uncut surface. So the top bottom, basically, we put the cut surface down in the back into the gyratory mold. So we applied the tack coat to that uncut surface, put that cut specimen back into the gyratory mold. We put loose mix on top of it, compacted the mix, and then later determined the bond strength. And we did it again at 3 different temperatures after letting the specimens condition at that temperature for 4 hours. We used a test frame that was a servo hydraulic test machine, but we loaded all the specimens at 2 inches per minute and used the temperature control cabinet to maintain the temperature, and we captured the load and strain data with the loading system. So I'm not going to get into a lot of detail on the results. I do want to point out a few things. Number one, we found different. We saw the effect of the gradation, the mixed gradation. The coarse mixes were not very sensitive. This is at 140 degrees, so this is kind of a very high temperature range that we worked at. The coarse mixes at 140 degrees was not sensitive to the types of tack, whereas the fine graded mixes was. In fact, the PG 64 minus 22 gave the highest tack. That's the kind of pinkish bars, and that's regardless of the confinement or the normal load, and regardless of the tack coat application rate. At 77 degrees, we did see more of an effect on the binder or the tack coat material for coarse graded and fine graded mixes. But generally, in most cases, the PG binder was among the best, not always the best, but generally among the best tack coat material in this experiment. One of the things I want to point out is the effective temperature. Obviously, with asphalt binder, we're talking about a temperature of viscoelastic material. So as the temperature goes up, its strength or stiffness or shear resistance is going to go down, and that's very obvious in this shear test. At 140 degrees, you see really low bond strengths, and that's probably the critical condition in the field, is when you have pavements that are very hot in the summertime, and they're going to have the lowest shear strength. At 77 degrees, we got an effect of a lot of the factors. It wasn't so sensitive here to the normal load. That's the 3 different bars at 77 in the middle. And at 50 degrees C, so at lower temperatures, there's very high bond strength unless there's some debonding occurring. So what we ended up recommending and settled after this phase one part, the laboratory part of the experiment, was the simplified bond strength procedure. And we picked 77 degrees as the test, and that's primarily out of convenience. It's easy to test that temperature. We also selected to use no normal pressure, no normal force. So you just put the specimen into the shear device and you go with it. At that temperature, and even with no normal pressure, the test is sensitive to the key variables, including the tack coat type, the application rate, surface texture of the mixes, and so forth. This is really convenient and gives us the ability to test the bond strength of cores. And for most conditions, as I mentioned before, the PG6422 straight binder provided a better bond strength than the two emulsions that we tested. We also observed that the lower application rates in the laboratory test provided the higher bond strengths for all the tack coat types. So sometimes you think, a little bit is good, a little bit more may be better, but that's not always the case in the case of tack coats. So we also did, as part of this project, a field validation phase, and there's two parts to this. Part one was where we went out and we built test sections on 7 field sites around the state. And each of those test sections, or each of those projects, we had 3 different application rates, and we took cores after the asphalt overlay was compacted and cooled. Part 2 of the field validation work was going out to field projects around Alabama where there were slippage failures. And we took cores both in the area where there was slippage occurring and on the same project away from that slippage area so that we could have kind of a bond strength comparison of the good and bad areas. On the part 1 of the project where we were building test sections, we used the technique to measure the application rate. It's an ASTM method, ASDM 2995. And it's probably a technique that's not used widely. At least I know some people are probably familiar with it, but basically it's putting out geotextile fabric, a non-woven geotextile fabric cut into squares, or you can use carpet squares. There's some guidance in the ASTM standard there about how to do that. But you can lay these across the width of the lane that's being tacked. You can do them also in the longitudinal direction. But it's a good way to actually measure the application rate. In the case of emulsions, you've got water and the residual asphalt. So you got to let those pads dry out, put them in a temperature controlled oven to dry them out to a constant mass. And then you have the residual rate. And that's really important because the other methods of measuring tack coat application can fool you. One of the ways that a lot of people say, well, they'll just ask the tack coat driver, tack coat distributor driver, what the computer says on the distributor computer. Those computers are notoriously inaccurate. In fact, in my work, I've yet to find one that gave the actual application rate that we were shooting for in an experiment. The other thing is that some states allow you to dilute the emulsion if you're using an emulsion for tack coat. And there are different ways to dilute emulsions. Some states do not allow you to dilute the tack coat, but anyway, what you're measuring with the computer is the total asphalt. Now you can correct that if you know how much water is in the emulsion, but that's a test that you got to go back to the lab to determine. The other way is to measure the volume of the distributor, measure the volume of the emulsion in the distributor tank before and after a set distance, and then how much volume of tack was applied over that set distance, and you can calculate a spread rate that way. But again, what you're getting is the total emulsion spread rate, not the residual binder, and that's the more important number to look for is the residual tack coat. All right, so for recommendations from the Alabama project, the first one that we did was the simple bond strength test is capable of measuring the effects of tack coat type, the application rate, and surface texture. And from that study, we recommended 100 PSI as a preliminary criterion. As I just mentioned, tack coat application rates in the specifications should be specified in terms of the residual asphalt, how much asphalt is actually on the surface. We did see the effect of milled surfaces versus unmilled surfaces. As Nathan mentioned, milled surfaces typically have better bond than unmilled surfaces. I'll give an exception to that from another study in a little bit. We saw that bond strengths develop quicker for a 64 or 67 minus 22 regular binder. And for a non-tracking tack, which wasn't used in the laboratory study, but it was used in the field phase, the non-tracking tack. Some of the observations from the forensic part were that most of the slippage failures were often due to construction issues, like improper tack application, dirty surfaces, mixed segregation. And I think surface cleanliness is really an important thing that Nathan's already mentioned, and I know Jack will talk about that as well. I mean, Sean will talk about that a little bit later. We did see that no slippage occurred where the bond strengths were at least 80 psi, and so that sort of helps support 100 psi as the criteria from the preliminary work. We also saw that milled surfaces generally provide good interface friction, as Nathan mentioned. And what is apparent is that better training is needed for inspectors and for paving crews on what a proper tack application looks like. Now, more recently, there have been some other studies that developed other bond strength procedures. There's an AASHTO standard developed by Louisiana. It is similar to the method that we used in the phase 1 work at NCAT, and it requires a normal load. But the loading rate that they have in this standard is much, much slower than what we have in the LDOT or the NCAT procedure. And then there's also more recently some work with the New Jersey DOT. They have a bond strength test, and it's much like the Alabama method and the method that Sean is going to talk about in just a minute. Let me give a few minutes about the New Jersey study that was much more recent. It's just a couple years ago. This project was to evaluate the bond strength on typical nighttime projects, which is common probably in a lot of places, but certainly common in New Jersey. The second objective was to evaluate the between lab variabilities of the New Jersey bond strength tests. We also wanted to evaluate the effect of coring relatively soon after the overlay, and then waiting 2 to 3 weeks after paving. And then lastly, we wanted to evaluate the effect of cores taken across the paving lane. So there was some expectation that we would have lower bond strengths in the wheel pass, and I'll explain that a little bit more later. And so we want to see if that was true. All right, so for the New Jersey project, cores were taken from 8 projects around the state. All the cores were taken by the same crew. 6 of those projects included milling and then cleaning of the milled surface, tacking, and then paving all in the same night. The other 2 projects were just overlays on recently paved asphalt surfaces. And the three labs involved in this work were the New Jersey DOT, Rutgers, and NCAT. So on each project, we got cores from 5 different locations or longitudinal points down the length of the project. And then for each of those locations, we took cores in different location across the lane. So location 1 was more toward the middle of the pavement. Location 2 was supposed to be in the wheel path. Location 3 was supposed to be between wheel paths, and so on. The black dots represents the cores taken at 1 to 3 days, and then the white circles represent cores that were taken, after 15 days, 15 to 30 days. So same location, just difference in time. Now, each of the labs were just given one of those cores from the 3 days or the 15-day plus coring. So for each project, NCAT got 5 cores, New Jersey DOT got 5 cores, and Rutgers got 5 cores. And it's those 5 locations representing the entire project. And I'm going to jump right to the findings from this study. First of all, we saw that 64 of the 240 cores, about 27%, debonded during coring or during shipment to the labs. And they took care to make sure that the cores were well protected, put them in concrete cylinder molds before they sent them to us. And so they weren't mishandled. Cores from the projects with milled surfaces on the New Jersey project had lower bond strengths than from the overlays on a new asphalt layer. My hypothesis here is that since they were paving, milling, cleaning, tacking, paving all at night in one, probably less than 8-hour shift, that I don't think the surfaces were getting cleaned well in some cases. We didn't measure cleanliness. We weren't there to really observe it. Saw just some pictures from when they were doing the coring, but that's my hypothesis. I don't think they were getting some of the dust, the debris from milling out of the milled surface with the textures that they have. In terms of the analysis, we saw that bond strength results of from the 3 laboratories were not statistically different. There was some bias, but they were not statistically different because there's significant variability with bond strength testing. We did see that the time of coring, the 1 to 3 days versus 15 to 30 days, also was not statistically significant. And lastly, the location of the cores across the paving lane was not statistically significant. That was a surprise to me. Overall, we saw bond strength variability on projects that ranged with coefficients of variation from 14 to 78%. Now that seems like a lot of variability, and certainly 78% is very high, and there were several projects that had above 30% COV. But that includes the sampling, basically where we're coring, the testing, and the construction variability. So I wanted to kind of wrap up with a few slides about what happens in the real world. And I've titled this slide, The Good, the Bad, the Ugly, what looks like a good tack coat, what's not a good tack coat, and what's really ugly for a lot of things. So milling, we've talked already a couple times, Nathan and I, about milling, usually providing some texture, which helps bond strength. But there are different textures left by milling, and probably very few states have a texture requirement. I think Sean may touch on that a little bit. But scabbing, I think, is probably a more common problem than we would like to admit. So scabbing is leaving a thin, incompetent, or poorly bonded layer after milling. And that scab will result in a weak plane, not between what's tacked and what's on top of it, between that scab and what's underneath it. And that's obviously going to lead to cracking or a debonding issue or a poor performance. So my question to you is, what should you do when you encounter scabbing? Most people say nothing. Cleaning the surface can also be an issue. And I mentioned in New Jersey, my hypothesis is that we weren't getting the surfaces well cleaned. And so another hypothesis is that probably the best way to clean a milled surface is to allow traffic on it for a day or more. Traffic does a really nice job of cleaning off pavements. Sometimes you don't have that luxury, but I do think that is a good way to clean surfaces. There's lots of good information on tack coat applications and how to measure that, and I'm not going to go into much detail here, but you probably all have seen variations. Another issue that we don't talk about very much is tack coat removal, and the reality is a lot of tack gets picked up by the construction equipment, by the trucks, by the MTV, by the paver, and so the most critical area of the pavement that needs a good bond, which is the wheel paths, is probably where we have, in a lot of cases, no tack. And this is what happens to the tack that gets picked up on those, haul trucks. It gets deposited somewhere else, and that's not good aesthetically or on a safety aspect. That's not going to be a good place to be slamming on your brakes. So what can you do? Non-tracking tack is a really good technology. Surprisingly, only, at least as a survey that we have maybe 5 years ago, there were only about 20 states that allow non-tracking tack. And the most common product is the non-tracking slow set 1HM emulsion. And Blackledge is the developer of the technology, and they're probably the most common supplier. Another way to make sure you don't get your tack picked up by your paving equipment is to apply it with a spray paver. So the original spray pavers were the McConaughey kind of paver used for a Nova chip application. And each of these, you have a large tank that has a capacity to hold the emulsion, and that tack coat is applied. In the bottom right picture, there's spray bars right there in front of the auger box on the paver. So that patent expired, I don't know, maybe 5 to 10 years ago, and now Aztec has a spray paver and Vogley has a spray paver. So you can apply that tack material right in front of the mix, and that's what you see on the surface in the bottom right. It's brown. That means it's not broke. The water is still in the emulsion. But as soon as that hot mix hits that unbroken tack, it will flash the water off, and you'll still be left with the residual binder. So I'm going to wrap it up with factors that affect bond strength. We've already talked about milled versus unmilled. Milled is typically a much higher bond strength than unmilled, but there are exceptions to that. Cleanliness of the surface is important. Residual dust will always minimize or reduce the bond. Tack coat types do matter. Emulsions, trackless tack, PG binders can all provide good bond if they're applied well and the surfaces are clean. Some states test tack coat quality. Usually it's a while before we get those results back. Application rates is kind of a hit or miss on how that's done. And then there's always a question, how much of that tack coat actually stayed after the trucks and MTVs and paver went across it. Mix gradation can have an effect. The literature is inconsistent about that. We certainly saw in the NCAT study where fine mixes provided a better bond strength than coarse mixes in the laboratory. And then time and traffic. Bond strength typically improves with time, although it wasn't significant in the study that we did for New Jersey. So the key takeaways. Number one, a good bond is critical to the performance of flexible pavements. Number two, several studies have shown that bond streak is clearly a problem on a lot of pavements. And there are numerous factors that can impact bond strength. Measuring bond strength is the only way to ensure that a good bond exists. And with that, I thank you for your time and apologize to Sean for running over a little bit on my time.
All right. So I'm going to talk a little bit today about our experience in West Virginia with bond shear strength testing, developing a specification, implementation, and a few things that we've learned along the way. Back around 2011 or 12, we noticed or we identified the need for a change. We were seeing poor pavements, increasingly poor pavements. There was a decrease in funding availability. As a result, there was a decrease in the asphalt design thickness. We also took notice of, and I think Randy mentioned this, poor tack code efforts and insufficient inspection, which is on us. But I guess we looked at all the ways we might be able to address that. And to help fight this losing battle. So we knew we were seeing a lot of distresses and failures, slippage, delamination, cracking, and we also know that all those things lead to a reduced pavement life, right? So as a result, we developed what we call our asphalt super specification, which I didn't name it that. I think maybe somebody in this in the room today may have named it that. We'll get to that a little later, but it's section 410 of our specification, and it applies to interstate and highway projects. It also applies to NHS routes now. It didn't initially, but it does now. We use square yard payment. There is a thickness disincentive, and it is percent within limits. Pay factors include percent asphalt, minus 200, mat and joint density, and bond strength, which is what we're here to talk about today. We did have a little inspiration along the way. I feel like we owe it to all the great folks who put in time researching to make mention of this, even though Randy mentioned it. Some of our inspirations were the NCAT reports 5-08 and 12-04, ALDOT's 430 testing manual, which is determining the bond strength between layers. Florida DOT's bond test FM 5-589. The FHWA tack coat workshop, they went around to many states. We actually participated, and the result of that workshop was the tack coat best practices tech brief that I think Randy may have mentioned. And last but not least, even Travis Walbeck. I'm sure many of you know Travis, but he worked for highways in West Virginia prior to going to NCAT, and he was a big part of the implementation of this specification. So this is a materials procedure, and it's MP 401-07-23. It is the guide to determining interface bond shear strength of multi-layered asphalt pavements. I realize that you probably have a tough time reading this, but I'm going to clarify some things about it here on the next couple of slides. So the purpose of MP 401-07-23 was to establish our approved method for measuring interface bond shear strength. It applies to both new construction and existing pavements. We do use it to evaluate asphalt layers on PCC, and we do use 6-inch core samples. I did include a link to the MP in case anyone who's here today would like to see it. We will provide, I'm guessing, the slides at your request. I have to mention also that for cores over PCC, we do not enforce the penalty structure. So as a part of this procedure, we condition the test specimens at 77 degrees Fahrenheit. This is generally achieved for us in our specific gravity baths that we have readily available and already set to 77 degrees. We place the core in the device so that the direction of traffic is in the same direction as the load. And generally, there's an arrow indicator on each sample. Once in a while, we'll get one without one and we'll scream. But so part of the process is we need to know the direction of traffic, and we tell all of our field folks to please put an arrow indicator on each sample. We're going to center that interface of between the overlay and the existing layer, between the reaction frame and the shearing frame of our bond strength device, which I'll show you here in a few slides. And we're going to apply displacement continuously at 2 inches per minute until there's a failure. We use the Marshall stabilometer. Most of the reason we use the Marshall stabilometer is because we already had the equipment in place at the Central Materials and at all of our 10 district laboratories. And so it just made sense. We did establish a 100 PSI minimum threshold. We looked to NCAT's report initially to establish that. And then WVU also performed some research for us that led us to that same conclusion. So bond shear strength is calculated as the maximum load divided by the cross-sectional area. I've included the actual calculations that we use here in case you're interested. But in order to calculate bond strength, you need to know the maximum load applied to the specimens in pound force, which is the information that you're going to get from that Marshall stabilometer, and the cross-sectional area. And in order to determine the cross-sectional area, we use pi times the diameter squared divided by 4, and we average the diameter of the test specimen. We take four measurements on that test specimen and average that. So we want to record the failure surface, whether that's the interface, the existing layer, or the overlay. Let's see. We want to document the interface appearance. That might be if there are any contaminants, striations, stripping, any kind of tack streaks, anything that you see that might be of importance later on if there's ever a question or a problem. And I also want to mention that, which I already mentioned, that this is a percent within limit spec, but we take 5 cores per lot. We have 2,500 ton lots and 500 ton sublots. So here's a photo of our old faithful proof of concept bond strength device. She isn't very pretty, but or functional for that matter. But we do still have her, and she lives happily on a shelf in our asphalt lab. And here is our production device. So as you can see, it's a bit more refined. These were all manufactured in-house by a longtime employee who had a background in machine work. He retired a few years ago, and I reached out to him recently to gauge his interest in maybe creating a few more of these, and I believe his reply was something along the lines of hell no. And this is an actual video of the performance of the test. So some of you may recognize that face. That's John Crane. He's the former West Virginia asphalt engineer and the current director of the Asphalt Pavement Association of West Virginia. He was a baby. All right. So this is the bond strength page of our T432 PWO workbook. Each of these single pages represents, I should say, a 2,500 ton lot with five 500 ton sublots or 5 tests per lot. I realize it's probably tough to see some of these. It's just meant to be an illustration of how we document the core measurements and the data. If anybody's interested in seeing our actual workbook, I'd be happy to let you see it. Just let me know. And this is a summary sheet from that same workbook. So there's a lot going on here, but I'll just zoom in on the bottom area for you. And you'll get to see the breakdown of the lot payment. And it is based on the PWL of each pay factor. In this case, the contractor received a $2,000 incentive and an overall bonus. You can see the total bid price and the total payment. So they received an overall bonus of around $6,000. So what are some of the challenges that we see? There are always a few challenges that we look to overcome. Randy talked about the importance of cleanliness and good tack coat practice. We also want to consider the existing surface condition and the texture. So we know that a uniform surface texture allows for better bond. And as a result of that, we require fine milling. Sorry about that. We require fine milling for all 410 PWL projects, and we require macro texture testing to make sure that we're getting what we pay for with the additional expense. We do have a materials procedure for this macro texture testing. Shown here, it is MP 401-0724. I've included a link to it on the next slide as well. To perform the test, we simply spread a known volume of media. We use glass beads in West Virginia with a standard hockey puck. It's a very simple test. Measure the diameter in 4 areas and take an average. Some of you might also know this test as the sand patch test, which is ASTM D965. And here is that link that I included in case anyone wants to check out that materials procedure. So scabbing, I know Randy touched on it a bit. Maybe Nathan did, but I'll just talk about our experience with scabbing. I'm sure you all know what scabbing is, or let's see. But it's an isolated or sometimes widespread patches of old pavement after milling. We have, in our experience, encountered it more often since we've started to pave these past PWL projects. The new lift might bond to the scab material, but the real weakness remains underneath of that scabbed area. And it's almost always going to be an area of weakness, and it's going to affect your bond strength result, and it's going to make the core failure mode difficult to interpret potentially. All right, so what can we do to address some of these things? If we encounter scabbing, we can always remill or remove unstable areas down to sound areas. Randy mentioned that's not something that we normally see. It's just an option. If not, we can try our best to remove any loose areas and make sure that they're clean. Verify good tack practices, and we want to certainly document the condition so that results are fairly interpreted. you certainly don't want to hold something against the contractor that's out of their control. We can also take pretty helpful preventative measures. We can talk to the designers and ask them to review the history of that pavement prior to the design, note the previous lift thicknesses, and then they can mill accordingly. We can ask the milling contractor to avoid leaving areas of scabbing during the milling process. Just talk to them and ask them to address the issues as they're encountered. It's always a good idea to mill trial areas just to assess the depth and the texture before full production begins, and make adjustments accordingly, right? And always, always, always keep a clear line of communication open with industry personnel. I mean, that's super important. So, if you perform bond strength testing for any amount of time, you're going to always have a few particular questions. One is, why are we seeing zeros or failures? A few things you might want to pay attention to are the coring practice. So, has the area cooled sufficiently? Time is money. Contractors tend to rush, but cooling sufficiently can mean the difference between good bond strength and pulling that core out of the hole at the interface, right? Another is, are they coring completely through the underlying layer? And believe it or not, we see it more often than you think. Sometimes you just have to ask them that question. Are you sure you're coring completely through the underlying layer? What type of extraction tools are they using? I've seen everything from screwdrivers to pry bars and pretty much everything in between. So another question is, when should we take the core, right? Will the bond strength improve if we wait 3 days or 7 days or 14 days even? So to help us answer that question, we teamed up with industry and performed a timing study. This is just a photograph of some of those core samples that we took. We evaluated 7 different lots on an interstate project, and we tried our best to treat everything the same application, tack application, I should say. Try to keep a consistent roller pattern, consistent coring practice, and even consistent personnel to do the coring. So day 1 of this timing study consisted of what we called early coring, I guess, although that's our normal time frame, so it's really not early coring to us. Day 3 represented a short waiting period. Day 7 was our intermediate interval, and day 14 represented our extended waiting period. So we wanted to see whether coring at these intervals made a difference in the bond strength results. And the moral of the story is, waiting did not produce a statistically meaningful change in the bond strength. We do see a slight improvement. I think Randy mentioned this as well, long-term under traffic, but obviously you can't wait a year to take that core, right? All right, results. So our initial special provision was written in 2013, and it didn't change, but it became a full specification in 2017. But essentially, as you can see here, we said that if you use a tack coat, the negative adjustment does not apply. So if no tack coat is applied in accordance with Section 408, which is our tack specification, then the following price adjustment will be applied for bond strength. The negative adjustment did apply to any failures if by chance you did not use a tack coat, and a few contractors tried us on that. But you can see here in this bar graph how our average bond strength improved over time. So this 2013 to 2018 time frame is under the original special provision, and once the specification went live, but the language in the specification hadn't yet changed. So we are only penalizing if we don't use a tack coat. But you can see that we still saw improvements over time, and this all of these averages also include zeros. So you know, pretty good results. So in 2019, along came our current specification, and this time around we stand silent on tack coat application. But now the negative adjustment is in effect for every sample. And we also offered an incentive for good bond strength results. So you can see our positive and negative adjustments listed there. And those are still the same adjustments that we use today. And as an update, so this is the bar graph that represents the time frame after the implementation of the full specification. In 2019, we did see an improvement over time. These averages also include the zeros, and we noted that we did see a significant number of samples in the 200 to 300 psi range, which is fantastic. And just as an example of the projects we evaluated for some of these, we're showing the information from 2024, where we had 19 projects statewide with a total of 875 bond core samples and average bond strength of 221 psi. All right, some things to consider. So in our experience, non-tracking tack seems to produce the best results. We see a lot of the NTSS1HM emulsion, that Randy mentioned. We do also see some hot applied non-tracking tack. Tack application rates correlate with good bond strength most of the time. And that we have experienced the highest percentage of failures on multi-lift new construction pavements, which we said earlier that, you know, that's we tend to see better bond strength in milled areas, and also in super elevated areas, uphill areas, and downhill areas. So some unknowns still remain. We do continue to work with researchers and industry, and hopefully one day we'll be able to answer more of these unknowns. Until that time, we'll keep up the good fight. So some key takeaways. Nothing compels the use of best practices like an end result specification with incentives and disincentives. And that's something we truly believe. Also, industry is resourceful. If you give them an end result specification, they'll rise to the occasion and find a way to make it work, to perform better work, and it'll just improve exponentially over time. So our specification has led to consistent bond strength improvement over time, which we showed on the bar graphs. We've seen fewer failures and distresses, a lot fewer, I should add. And I guess lastly, I want to drive home that there is an added cost to this bond strength specification, but we believe there's significant value in that added cost. And there's my email address. I think the questions they're going to handle a particular way.
Very good. So, Randy and Sean both pointed out tack issues are most commonly a construction quality issue. There may be materials related, but construction quality is key. Randy, I thought your slides about, the accelerated fatigue cracking, both middle up and middle down, was really insightful. And debonding can be a cause of accelerated fatigue cracking. So, what's on the surface, it may be being affected simply because you have slippage between layers. Temperature is going to be a big factor in getting different bond strengths, and so comparing bond strengths across different temperatures and, for that matter, different loading rates is a dangerous task. You just need to make sure you understand the differences, and with higher temperatures, you're going to have much less shear resistance. There is a break-even point, where if some is good, more is better, but too much is a bad thing, and you cannot. If you have too much tack, um, there is kind of a break-even point. So more tack does not necessarily improve improved bond strength. That should say bond strength, not tack. Measure your tack rate. And so if you're a contractor, you ought to measure your tack rates. I like the little carpet square method where you're physically spraying over a piece of paper or a carpet square, and you know exact applications for gallons per square yard. Randy, I thought your points about specifying residual asphalt content, what's actually going to be there when you pave over it, gluing two layers together is what is important, not the diluted rate. What's the saying? Cleanliness is next to godliness. I didn't get that in my personal life, but on the roadway, absolutely. Clean the surface prior to overlaying, and traffic helps with this. And that way you remove any debris, and you make sure that you have a really nice surface prepared for tack and then overlay. If possible, remove scabbing. I'll have a question for you on this, Sean, here in just a second. So if you can remove scabbing, you should, but definitely remove obvious loose scabbing, and that's where a really heavy broom can help with that, to kind of pick up any of those loose scabs that need to be removed prior to overlaying. Sean, I thought you made a great point about milling trial areas, just to make sure that you got the depth right, so as a preventative measure to prevent scabbing, and also if to see what the texture is going to be like from that particular milling head. That's really important as you start looking at teeth wear and things like that on the milling drums. And I thought your last point was really helpful, especially from an agency perspective. End result specifications are effective at getting what you want. You have resourceful industry. They may not necessarily agree with it, but you have a resourceful industry who, if you tell them what you want, the industry side of the coin, they're smart folks, and they are able to achieve that. So I want to pause here and just thank both of Randy and Sean. I feel like I'm a broken record when I say this every month, but this is one of our best webinars. I don't know about the attendees, but based on the questions and me personally, I learned a ton, even just from sitting here for the past hour. So that was really, really helpful. Travis, do you see any questions that Randy hasn't had a chance to go over? I know Sean had a couple that he hasn't had a chance to see yet, so maybe we can skip to his.
So I think one of those is from our friend Matthew Hoyle, and he was asking there that in West Virginia, the who does the testing? Is it QA testing or QC testing? And I know the answer, but I'd like you to answer it, Sean. But he also asks in there if contractors are doing any sister cores for the bond strength testing.
Yes, and thanks for the question. We, as the division, perform 100% of the acceptance testing, and the contractors are most certainly taking sister samples. And they're sometimes using them to as a dispute tool, So yeah, but we see a lot of sister sampling for sure.
But do you see them doing their own bond strength testing?
Absolutely. There's probably about four contractors now who And we don't have a ton of paving contractors in West Virginia, so four of the larger paving contractors are performing their own bond strength testing.
Okay, great. Randy and Nathan both, I'd like you guys to weigh in on this one here. There's some questions about that higher tack rate and where that limit may be. Somebody was talking about that they spray back over the wheel pass where it got tracked up. They spray again, and they're nervous about that high end tack rate. Where
Hmm.
where do you guys see that point of diminishing returns on how much tack we're putting down?
Yeah, I haven't heard of that technique of putting tag back where it's been tracked off the pavement. I think, as I mentioned in the lab study, it certainly showed higher amount of tack is not necessarily better. It may actually weaken the interface by creating a little um, uh, kind of a shear plane there. That's just dependent solely on the binder, the tack binder. Anyway, so just be careful not to overdo it with that approach. I just don't have any personal experience with that.
Yeah, I don't have a number to provide, Travis.
Okay.
I've we've sprayed. We typically, what I've seen is like, 0.06 gallons per square yard. Some products are sprayed higher than that, like if they're kind of engineered products for that. Um, I don't have any personal experience with a breakover point where you point cross the point of diminishing returns and you actually start harming the pavement. I've seen photos of it though, but I don't have any numbers really.
Okay.
I think maybe the biocular neural network, the two eyes in the brain, will take you pretty far on that though.
So, so there was a little bit of work done before Sean was in his current role there in West Virginia, where they did half single application, so half a rate single application, double application, and triple the application rate, and they didn't find that it hurt the bond strength to the point that they were going to then find failures. And so I've always really wondered where that breakover point is, because I do have that concern, like you said there, Randy, that we get such a thick layer of binder in between the layers that we get a shear plane that would appear. So
Travis, I'm gonna jump in. There was a question to
yeah,
Sean. I think
yeah.
it may be the best question in the chat, in my opinion. Sean, you're showing these improved bond strength numbers over time.
Mhm.
Are you seeing better payment performance corresponding with those numbers? Basically, is your spec working?
Yes, I mean, I think the specification has improved, and I'm talking about the entire specification because our PWL specification addresses a lot of different things, including longitudinal joint. But yes, we're definitely seeing results. Of course, some of those numbers it's too early to tell. From the more recent years, it's too early to tell how the pavement. It seems to be performing well, but it's just probably too early to tell. But some of those past pavements that are still in service, absolutely.
Yeah, it's great. That's helpful. Travis, I think we may have time for about one more. Do you see one that we need to address?
Um, I think Randy's done a great job of answering those and putting that stuff together. So if you don't mind,
I
I'd say
see.
we, was
Yeah,
that?
Matthew, we love you. You're extremely active in the chat.
Oh,
I think this is probably the most questions we've ever gotten, at least in the past, year or so of doing this. So this is
yeah,
really helpful. Emails are on the screen here, Sean D. Jack at
yeah.
wv.gov, and then the three of me, Randy, and Travis. I would advise you guys to reach out to those to our presenters for questions on this. But in the interest of time, I do want to turn folks loose.
Okay.
And so we are going to kind of wrap it up from here. Travis, why don't you take it away?
So always want to mention that there's plenty of research out there and some great things that have been done at NCAT over the years. You can see that there's reports from the different test track experiments that were done clear back to the year 2000. We invite you to go to our website at ncat.us to look at those. Always want to see folks that visit Training in Your Pocket. Sean mentioned that there's the sand patch test that they use for their fine milling, and that's the only way they determine whether it's fine milling, micro milling, or standard milling, is by that texture depth that's determined from the sand patch test. Just so happens, Pat and Zach go through and explain how to do the sand patch test to include the calculations. So that's a great place to go learn about that process. Do want to let you know that next month our webinar will be on June 18th. We're going to look at the updated use of recycled rubber using the dry process. There's some really cool projects that have happened very recently. This is not last year's or the year before's information. This is some really new stuff that's been going on that we're excited to talk to you guys all about. That QR code is active, or the link, if you find the link, which is aub.ie/web series. That will take you to the registration for whatever the next version of this From Research to Implementation webinar is. So that'll take you to the June version at this point. Given that, I want to thank everybody for your participation. Fantastic. Thank you very much, Randy. Some great information out there for everybody. Sean, you as well. Some of those numbers were very exciting for me to see, having been involved with this years ago and not seeing the last couple of years worth of that information. So thank you both for all your contributions here. Thank you, Nathan, for always doing a great job of wrapping us up. And we'll see you all next month.